Okay, let's dive right into it. Could a radical, completely out-of-the-box scientific tool finally solve the mystery of Malaysian Airlines Flight 370? I mean, for a decade now, this case has totally baffled experts, right? It's spawned just countless theories. But what if the data to find the plane has literally been silently bouncing through the atmosphere this entire time? Today, in this explainer, we're unpacking a groundbreaking technological approach that is absolutely shifting the entire landscape of the search. Imagine if the entire globe was covered in invisible tripwires that could tell us exactly where a missing aircraft went. Sounds a bit like science fiction, doesn't it? Well, it's actually an incredibly real global network of radio pulses. We are talking about millions of low-power radio waves transmitted every 2 minutes by amateur ham operators all around the world. And every time a massive metal object, like, say, a Boeing 777, flies through these pulses, it creates a disturbance. It essentially trips that invisible wire.
313. That is the exact number of radio anomalies detected along MH370's flight path using this very technology. So we aren't just looking at one or two stray data points here. No way. We're looking at 313 highly specific disturbances right at the estimated position of the aircraft, recorded at 130 different points in time over its final flight. That's a massive amount of data.
So here's our roadmap for this explainer. First, we'll use this new data to map out the flight's final hours. Then, we'll take a hard look at the physical ocean debris. And finally, we're going to unpack the massive billion-dollar conflict over where the next underwater search should actually take place.
The absolute crucial piece of the puzzle is understanding the technology making all of this possible, and that is WSPR. It stands for Weak Signal Propagation Reporter. You can kind of think of WSPR as a multi-static, multi-frequency system with over 6 million distinctive links globally. Now, while it was originally designed just for amateur radio operators to test signal strength, independent aerospace engineer Richard Godfrey realized something amazing. He realized it essentially acts as a massive statistical radar net spanning the entire planet.
Okay, here's how this tech actually works, basically in 3 simple steps. First off, transmitters send out long 2-minute radio pulses. Second, a passing aircraft acts as a massive reflector, disturbing those waves, honestly very much like traditional radar. And third, the WSPR receivers on the other end log the metadata. If an aircraft passes through, it creates a little anomaly in the signal-to-noise ratio, or the frequency. By statistically analyzing these anomalies and cross-referencing them against known aircraft positions, researchers can track a plane long after it vanishes from military or civilian radar screens. It's really brilliant.
All right, let's get into mapping the flight path and uncovering those mysterious final hours. You see, after the last military radar contact, investigators were effectively flying blind. The old ghost flight theory assumed that from that point on, the pilot was incapacitated, and the aircraft just flew in a straight line on autopilot until it completely ran out of fuel. But the WSPR data, it tells a fundamentally different story. By tracking these radio anomalies for the next 6 hours, the data indicates we had an active pilot at the controls, someone making evasive maneuvers, changing speeds, and altering direction right up to the very end. This data strongly suggests there was a conscious effort to obscure the plane's final destination. That brings us to the debris debate and what the physical evidence actually tells us. Now, data on a computer screen is one thing, but to truly corroborate these radio signals, we have to look at the physical evidence pulled straight from the ocean. Exactly 43 items of floating debris have been recovered by locals and independent investigators over the years. And let me tell you, these 43 pieces of twisted metal tell a highly specific, totally undeniable forensic story. Let's really look at what this debris actually means. First, the flaperon found on Reunion Island shows the flaps were retracted at impact. Why does that matter? Well, if a pilot were attempting a soft, controlled ditching on the water, those flaps would definitely be extended. Furthermore, just look at the fragmentation. The average piece of recovered debris weighs less than 5 kilograms. That implies the plane shattered into roughly 36,000 pieces. From interior cabin dividers to exterior pieces of the tail, this physical evidence completely rules out a soft landing. It points straight to a high-speed, catastrophic impact, which perfectly aligns with that chaotic, active pilot scenario suggested by the WSPR data.
Now, you might be sitting there wondering, okay, is this just some crazy fringe theory? The answer is a resounding no. To ensure this methodology is rigorously tested, an independent 6-month, large-scale validation study is currently underway. It's being spearheaded by Professor Simon Mascal and a whole team of Bayesian statistics experts over at Liverpool University. What they're doing is applying immense computing power to test this WSPR tracking against thousands of known ordinary commercial flights. The goal? To definitively prove its reliability.
Having this kind of massive academic backing gives the WSPR data incredible credibility. Professor Maskell's confidence is super telling here. He stated it's more likely than not that WSPR detected MH370, adding that if he thought it was a dead end, he wouldn't be wasting his time. When leading academic statisticians are stating they're finding a tangible signal within the noise, it elevates all of this from a mere hypothesis to a highly actionable roadmap. And this rigorous validation is exactly what's setting the stage for a potential new underwater search.
Which leads us to our final section, the next search and a very real billion-dollar dilemma. With this breakthrough pointing to a specific crash site, you'd probably think the next steps would be straightforward, right? Well, instead, we are seeing a massive dilemma unfold. Let's compare the two current proposals. On one hand, the WSPR proposal pinpoints a tight, completely unsearched 30-kilometer radius at 29 degrees south. But on the other hand, the marine robotics company, Ocean Infinity, wants to search a massive 15,000 square nautical mile area further south. The real catch here? That massive area has actually already been searched twice before. As you can imagine, this is causing some serious tension within the aviation community. Ocean Infinity operates on a no-find, no-fee agreement, meaning they absorb massive upfront costs. Because of this, some independent researchers are arguing that authorities might be taking the safe, politically acceptable route by researching those old ghost flight areas while completely ignoring the new WSPR data. It definitely raises a difficult question. Is researching an empty patch of ocean for a third time a genuine attempt to finally find the aircraft, or is it more of a token gesture to mitigate financial risk?
So, as we wrap up this explainer, we're really left at a crossroads. We have this revolutionary radio technology, it's corroborated by physical forensic debris, and it's heavily backed by leading university statisticians, all pointing to a completely unsearched 30-kilometer circle on the ocean floor. We have to ask ourselves, when the ships finally sail again, will authorities embrace this breakthrough science and look in the right place, or will bureaucracy and a fear of the unknown ensure that aviation's greatest mystery remains lost to the depths forever? Thanks so much for joining me for this explainer, and as always, keep questioning the data.